네. I will present some optimized inversion algorithm for special case of extension field. So as you can see in the code, like there is already optimization for quadratic extension for simple version of making some new formula for the base field elements. So you can just do some base field operations for getting an inversion in the quadratic extension field. And for the cubic extension field, so there is some kind of like abstraction for getting inversion by calculating the inverse matrix. And also for the quartic extension, there is a tower extension for the quadratic extension field. So you can make a reduction from quartic to quadratic, and you can do one more quadratic extension field, get inverse, and then you can get the base field operations for getting the inverse. So yeah, in this post, just it is explaining just two inverse in the cubic and quartic. For the cubic extension field, so it makes some matrix, which is doing some multiplication for one element over extension field. And then, so then you can see like getting an inverse is kind of like getting the inverse matrix for this mx. And then, so there is a kind of like a trick or the calculation method, which is Kramer's rule. It is it's kind of like a very old and simple method for getting the inverse matrix. So this is you can calculate the determinant and also for some adjugate matrix, which is calculating the cofactor for the matrix and then do some calculation. But I didn't put some like explanation for this. Do you think should I add some explanation for the getting this adjugate or is it okay to just pass it?
Oh yeah,
Yeah, and so I think like it is very like well-known algorithm for getting some inverse metric. So I will just skip it, and then after set up this equation, then you can calculate with this formula for the all the variables are known for at the compile time. I mean, yeah, in the like for the structure in the compile time. So it is just changing the getting inverse matrix to just simple formula and then calculate with the just a base field operation. Yeah, and also this is getting inverse for the quartic extension field. So if you want to use the same method, which is the Kramer's rule in the quartic extension field, then you should calculate the like for each like 3x3 matrix, inverse matrix, so it can be really exploded. So it is just using some tower extension for the quadratic field. So it is just splitting the values to set the structure of the same way of the quadratic extension field. So it's just splitting the values to this way. So as you can see, the like original form is 2u to the 3, but you can split to this like just 1 degree 1u for each. And then do some like basic math for just getting some inverse over this one first, and then like you should do one more time of this making what should I say? Yeah, so getting some inverse over quadratic extension field. So, and then you can just get the result over the quadratic extension field, quartic extension field. And I added this section after the Ryan's review. And this is the Ito-Tsuji algorithm is the original algorithm, which is using the Frobenius endomorphism. So then you can see the summary is there is a fixed number of operations. So it reduces just 3 multiplication for the cubic. And then in quartic, then you can see the like 2 scalars and 6, like approximately 6 multiplications are reduced. But if you do some like higher degree like extension field, then the Ito-Tsuji will like increase this just like O of log k. So the degree increasing like doesn't make any that explosion of the calculation. But these specific optimizations cannot be applied to like higher degree. So I think like tower of some like quadratic, then it can be applied as well, and you can just compare those two algorithms. But I don't think like matrix based will be used in the higher degree. Yeah. So I think like Ito-Tsuji just makes some like constant number of operations for just calculating the like Frobenius or the norm and yeah those ways. So maybe so I added some appendix for the checking the possibility of inversion over a quadratic tower. So there are some requirements for do like quadratic extension for each quadratic tower. So you can check the requirements, and then if it satisfies, then you can use the tower extension for like using same way to just doing some recursive way to get some inversion. Yeah. That's all for just simple explanation.
So Ito-Tsuji is kind of
It's just a default algorithm that you explained the using the Frobenius.
I
That's
see.
the name of the algorithm.
I see.
So maybe you can just add some the name of algorithm in front of the page that is inversion beside.
Yeah.
Yeah, maybe just for